All right, we're going to go over chapter 4.3 and 4.4, mixed entire radicals and fractional exponents. So when we're talking about radicals, we're talking about this thing, square root, but also it can be like this, like cube root, fourth root, anything like that. So that's radicals. Mixed and entire, an entire radical is something like this, where the whole number is underneath the radical sign, the root sign, whereas a mixed radical is something like that. Remember when you did fractions and you had something like that, a mixed fraction like 2.5? It's the same idea. Mixed is when you have a coefficient basically, and then a number under the radical there. So let's go through how to switch them. If we have something like square root 80, what we have to do is we know that we could write it like this. Two numbers under a radical sign can be multiplied together to create something new, like 2 times 40 is 80. But this isn't actually how we're going to simplify it. We want to simplify it into something that is a perfect square. So I know that some of the perfect squares, I'll write them at the bottom really quickly. Okay, when I look at this, for 80, 16 is a factor. 16 times 5 is 80. So what I can do is square root of 16 turns into 4. And then root 5 still root 5. So the idea is that when we're simplifying it, you want to rewrite it as something that is two things multiplied together, and you want one of them to be a perfect square so that you can simplify it that way. And then that's it. That's the entire radical, the mixed radical. We can also do it with something cube root. We just need to think of what is a perfect cube. So I'm going to write out my perfect cubes here so I can see them. I think it's 27. I have to check. No. Okay. So the only one that worked for me was 8 and 18. So the cube root of 8 is 2, and then the cube root of 18 can't really be simplified because none of these factors fit. So again, we rewrote it as a multiplication of two numbers, 8 and 18, and then we simplified the 8, the cube root 8, to turn into 2. Now, we can actually do the same thing, but go the other direction. So we have a mixed radical, and we want to turn it into just an entire radical. This one's actually easier. What we have to do is we have to change it again into 2 being multiplied. 3 doesn't change. We have to turn the 4 into square root of something. So we want to think, well, what square rooted is 4? All you have to do is, you can write it like this if you want, 4 squared square rooted, which is really 16. So we turn the coefficient, that 4, into square root 16. Now we can just multiply these together and you get 48, square root of 48. That would be the entire radical version and the answer. We can also do it with cube root. We'll do the exact same thing. And then we have to actually write what 3 cubed is, which is 27. 27 times cube root 2. And those multiplied together gives you 54. And that's our answer. So that's the basics for mixed and entire radicals, which is chapter 4.3. Let's also talk about 4.4, which is talking about fractional exponents. It's related to this. So most of the exponents we've been dealing with so far has been just basic exponents like 2 or even with negatives. The fractions work just add one more layer of complexity. When we have something like this, what happens is, actually we'll do an example over here. X to the 2 over 5, let's say. The x squared stays as normal. It's going to become x squared. That isn't weird. The cube, the divided by 5 part, becomes part of a radical. And whatever that number that was there as the divisor becomes here as part of the radical to tell us what degree we're doing to it. So in this example we have right over here, it's 24 to the power of 4 over 3. So that's going to become 24 to the power of 4 cubed root. Yeah, so that's how we would do that type of question. We can also do something like this one, the 0.75 to the power of 1.2, what we're going to do is we're going to rewrite that 1.2 as a decimal, or as a fraction rather. So 0.75 to the power of 12 over 10. That's the same thing. And then I'm going to reduce this because it's ugly. 0.75 is 6 over 5. Cool. So now 0.75 doesn't change with the 6. And then we have fifth root here. And that's the basics. There's one more example I wanted to do, I think. Yeah, so you know what? Let's do this one, but I want it to be 27. That makes way more sense. 27. So after we get to this point, what we can actually do is apply the numbers. So I'm going to do the cube root first because it's going to make this number smaller. So the cube root of 27 is 3. Because 3 times 3 times 3 is 27. Now we can actually do 3 to the power of 4, and it's not that big of a number because it's 3 times 3. Oh, sorry. Once we applied that cube root, it actually, the square root is gone. 3 times 3 times 3 times 3. 3 times 3 is 9 times 9. This is 81. So if we had tried to just do this in our head right away, it would have been complicated. But at the same time, you can punch 27 to the power of 4 divided by 3 in your calculator, and it'll still give you 81 as the right answer. So if you have access to a calculator, you can do these questions pretty easily. So that's it. That's how you do these types of questions, and that's it.